Okay, we're ready now for problem 31. And I see that problem 31 says find the exact value of the following expression. And here we have so this represents inverse sine function. What I always tell myself whenever I have an inverse function, I keep reminding myself this whole thing is going to equal an angle. Now the tricky thing about inverse trig functions is there are limitations on what the answer can be. In other words, I'm looking for an angle here, but when I do either an inverse sine function or inverse tangent function, the angle can only be here, like on the right half of the circle. And what happens is 0 is here, pi over 2 is here, but if we go down like in the fourth quadrant, we call these negative angles. So this is really different than, say, what the unit circle, where we just go counterclockwise all the way around. So anytime you have an inverse sine inverse tangent function, your answer has to be over here someplace. And then what makes it even a little trickier is if we ever do inverse cosine function, same idea, except the answer has to be between 0 and pi. So every time you start working with inverse trig functions, you got to keep this in mind. So a problem like this, basically you ask yourself the question, and what you say is, I'm looking for an angle, so when I take the sine of that angle, it equals 0. In a sense, in your mind, you're basically saying, okay, for what angle is the sine 0? Now in this case, it's pretty simple. It's right here, which would be 0 radians. All right, that's not too hard. Let's see if there are a few more on here. 32 says they ask for the exact value of the inverse sine of square root of 2 over 2. So once again, I ask myself, once again, I know this whole thing is going to be an angle. So I ask myself, what's the angle that when you take the sine, you get square root of 2 over 2? So this is where you go back once again to your unit circle, and you recall that the sine is square root of 2 over 2 right here at pi over 4. So that's your answer. And since pi over 4 is in the right half of the circle, that's perfectly fine. 33 is sort of interesting. It doesn't say find the exact value. It actually tells you to use your calculator, because this is not going to be one of our special angles. So on your calculator, they say they want the answer, so this is they want the answer in radians. So once again, this is going to be an angle. So make sure your calculator is set to radians instead of degrees. So I just hit 0.2 in my calculator. I go find, there's an inverse sine key. And it says round to 2 decimal places. So initially, it's 0.2013, and it goes on. But since I rounded 2 decimal places, 0 is my last digit. I look at the 1, since it's less than 5. the answer would just be 0.20 radians. Now, just to make things more interesting, they do these, what we call composite sort of trig functions. So 34, they take the inverse cosine of the cosine of 7 pi over 8. Now, let me tell you how you can view these problems, and sometimes these problems become very, very easy, but other times they become a little tricky. And the whole key is we're eventually going to take the inverse cosine. So, well, let me explain it this way. When you take the inverse cosine of a cosine, there's a chance that these two will cancel out, and you just end up with what you start with. But that doesn't always work. Let me actually give you another problem so I can show you. Let's just assume that we're not really paying attention, and we just assume the simplest idea that an inverse cosine of a cosine cancels out and you're left. So this one, we would say, well, these two things cancel out. The answer would be 7 pi over 8. For these two, they cancel out 3 pi over 2. Now, if you think about it, the last step of this was to take an inverse cosine. And from our little diagram I still have up here, inverse cosine has to be between 0 and pi. So this first one, whatever's inside these brackets, when I take the inverse cosine, I say it's 7 pi over 8. Is that a possible correct answer? Well, 7 pi over 8 is like maybe right here. And that is in the allowed and acceptable range for inverse cosine. So that makes sense. How about this one? When I take an inverse cosine, I get my answer to be 3 pi over 2. Where's 3 pi over 2? 3 pi over 2 is down here. In other words, my answer is not in the allowed acceptable range. So what you do in this case is you have to find the reference angle that's in the top half of the circle. Reference angle means the same distance to the x-axis. In this case, the reference angle is up here. So this is 3 pi over 2. This is pi over 2. So that's really not the answer. The answer is pi over 2. So in this case, you can't just assume, oh, the inverse cosine and the cosine sort of cancel out, and the answer is whatever's inside here. You can't do that. Bottom line is, in this kind of problem, if the initial value here for the cosines is between 0 and pi, then yeah, they cancel out and you're done. But if the initial angle is not between 0 and pi, it's not in the top half of the circle, then they don't cancel out. And you have to go find the reference angle and take it from there. All right. Once again, we explained that in the earlier video, but just wanted to highlight it. All right, 35. Now we're going to solve some equations with a trig function. It says solve the equation on the interval 0 to 2 pi. So the good thing is we don't have to worry about all the potential angles that are answers. We just have to worry about the ones between 0 and 2 pi. And here's the equation. And like I taught earlier when I went over this, it's really a two-step process. The first step is to get the trig function by itself on one side. And then after you do that, then you need to solve for the angle, solve for theta. So let's get the sine theta by itself. So I'll subtract 5 from both sides. Divide both sides by 4. So it's 2 over 4, which is 1/2. Okay, first step accomplished. I've now solved for the trig function. Second step is now, let's figure out what theta equals. Because the ultimate goal of this problem, when we say solve this problem, it's like theta is the variable. We're trying to figure out what theta equals. So now here we go again. I ask myself, I'm looking for an angle. Any angle between 0 and 2 pi. I'm looking for an angle. Then I take the sine of it. It equals 1/2. This is where you have to know the unit circle. So we say, okay, where on the unit circle is the sine 1/2? Or really the y value of the point 1/2. Well, that occurs, I know it's down here, pi over 6, over here at 5 pi over 6. It doesn't occur anyplace else because below the x-axis, those are negative numbers. So there's actually 2 angles where this occurs, so therefore my solutions are pi over 6 and 5 pi over 6. 36 is somewhat similar. Once again, they say solve for theta between 0 and 2 pi. So we're trying to solve for theta. Once again, 2-step process. Let's get the trig function by itself on one side, and then after that, we can solve for theta. So I divide both sides by 16. 4 over 16 is 1/4. Now I don't have cosine theta. Right now I have cosine squared theta. So what do you do to get rid of something squared? Take square root of both sides. Square root of 1 is 1, square root of 4 is 2, but don't forget now, since we're taking the square root of a number, it's plus or minus 1/2. So now we solve for the trig function. Now let's solve for the angle. Let's just make this clear. Let's break it up into 2 parts. So first we're going to look for the angles between 0 and 2 pi where the cosine of the angle is 1/2. And then we'll look for the angles where the cosine is negative 1/2. So if you think about the unit circle, where in here is the cosine 1/2? And you know what it is? Pi over 3. And we go down here to 5 pi over 3. Now where is the cosine negative 1/2? It's actually going to be here and here. So it's 2 pi over 3 and 4 pi over 3. So there are actually 4 angles for that. Actually all 4 of the points where the cosine is either 1/2 or negative 1/2. Now 37 is a little trickier. It's another equation to solve. Let me write it down and let me talk about why we have to really go about it in a little bit of a different way. Cosine 2 theta equals negative square root of 3 over 2. And of course, we're trying to solve for theta. So this is the third problem where I'm trying to solve an equation with the trig function. So what's the difference? Well, look at the first one I did. The trig function 4 sine theta plus 5 cosine. So the trig function is a sine theta, right? The trig function and then the angle theta. Second one, here 16 cosine squared theta equals 4. The key thing to realize here is that once again, inside the trig function is just theta. There's nothing else in there. It's just the angle. But now, look what we have here. Cosine 2 theta. All of a sudden, inside the trig function, it's not just the angle theta, but it's 2 theta. And that really changes everything. Now the way I like to do this, I like to use substitution. So I take whatever's inside the trig function, and I'm going to introduce this variable u. So I'm going to plug in u for 2 theta. Because when I do that, I can now go ahead and solve this equation for u. Use an angle, so I'm saying, okay, and here's the tricky part. This problem, it actually does say the answer should be between 0 and 2 pi, but be careful. You don't want to assume right away what your possible answers are going to be. In other words, I'm going to work this problem out, and I'm going to, well, I'll show you what I do. So let's just do it. What's an angle where you take the cosine, it's negative square root 3 over 2. There's actually two. The first one is 5 pi over 6. But in this case, I'm not going to assume from the start this whole 0 to 2 pi thing. So I'm going to go and add in 2 pi times k, right? Where k is 0, 1, 2, 3. But then I have a second angle because there's another angle that the cosine is negative square root 3 over 2. And that's actually 7 pi over 6. And once again, plus 2 pi k. Now, these are u's. I'm actually trying to solve for theta. So now let's convert from u back to theta. And what I do is I use the definition when I first introduced the u. So I say u equals 2 theta, but u also equals, the first one is 5 pi over 6 plus 2 pi k. Now if I solve this for theta, divide both sides by 2, I get 5 pi over 12 plus pi k. And if I do the same thing for my second possible solution, here's 7 pi over 6 plus 2 pi k, divide both sides by 2. 7 pi over 12 plus pi k. So really, these are my two solutions, but I'm not really finished because they want all the angles between 0 and 2 pi. I have to figure that out. So let's just say when k is 0, from that equation I get 5 pi over 12. From this equation, 7 pi over 12. When k is 1, pi plus 5 pi over 12, if I make this 12 pi, I think it's 17 pi over 12. And down here, I think it's 29 pi over 12. Now if I go 2, first of all I notice I'm going to have 2 pi plus this, so I'm already out of my 2 pi range. And the same thing down here. So basically it looks like I have 4 answers. And that should in fact be the solution. Oh, except I made a math error here. So it's been 19. When you plug in 1, 12 pi over 12 plus 7, 19. Sorry. All right. So that's how you work the problems when you have something besides just the angle inside the trig function. All right, looks like I have another problem to solve with a trig function in it. It's number 38. 2 sine squared theta minus sine theta equals 0. And once again, answers between 0 and 2 pi. So this is, once again, if we're trying to first solve for the trig function, well, the problem is I can't get the trig function by itself on one side because I've got sine squared theta and sine theta. What would you do instead of sine of theta? Instead of sine of theta, if I replace sine of theta with x, how would you solve this? The easiest way is to factor, and then you take each factor and set it equal to 0. Well, let's do that here. Let's factor out the sine of theta. So you have 2 sine theta minus 1 equals 0. Now you take each factor and you set it equal to 0. So sine theta is 0. When is that going to happen? What's the angle where the sine of theta is going to be 0? I think it's going to be 0 and pi. I don't put 2 pi down because 2 pi is not in my potential answers. Now I take the second factor, set equal to 0. Now let's solve, get the trig function by itself. Add 1 to both sides, divided by 2. Now I say, what are the angles where the sine is 1/2? I know it's pi over 6 and 5 pi over 6. So if I didn't make any mistakes, those should be my answers. Actually 4 angles. Solve this equation. 39 is one problem dealing with what we call trig identities. And they say rewrite tangent of theta times cosecant of theta in terms of sine and cosine. So basically we want to change everything to sine to cosine, which is what I do anyways normally. We know tangent sine theta over cosine theta times secant. Secant gets paired up with the sine. It's like a reciprocal. So 1 over sine. Now, hopefully you remember rules of math. If you have identical factors on the top bottom they cancel out. And we're left with that. All right, not too hard. (40) says use a sum or difference formula to find the exact value of the trigonometric function. So here they're asking us to find the exact value of this trig function, sine pi over 12, but they want exact value, which means no calculator, but pi over 12 is not one of my special angles. But in the instructions, they give us a clue as to how to try and solve this when they say use a sum or difference formula. Now I've got the cheat sheet for the test here, and you can see right here are the list of sum or distance formulas. There are 2 for cosine and 2 for sine, and this is where they're stuck 2 angles. So we've done this before. Basically, I need to find 2 angles that I can either add or subtract from each other that equal pi over 12. And just because I've done this often enough, if I take 4 pi over 12 minus 3 pi over 12, that equals pi over 12. But if I look closer at this, 4 pi over 12 is pi over 3. 3 pi over 12 is pi over 4. So really, I can rewrite pi over 12 as pi over 3 minus pi over 4. Therefore, my original problem, I can now rewrite it like this. And then I go and I look for the formula on the sheet. Looks like I've got a sine of an angle minus an angle. When you have a sine angle minus an angle, there's the formula. So it's sine of u minus v. And it equals sine u cosine v. Sine u cosine v minus cosine u sine v. And now I know that u is 1/3, v is pi over 4. So therefore I can say this is the sine pi over 3 cosine pi over 4 minus cosine pi over 3 sine pi over 4. Now we know all these. Pi over 3 and pi over 4 are special angles, so I can do those. Sine of pi over 3 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3. Oh, I messed up. Hopefully you guys are aware of that. The sine of pi over 3, square root of 3 over 2. Cosine of pi over 3 is 1/2. The sine of pi over 4 so now I have square root of 6 over 4 minus square root of 2 over 4. So if I combine these in one fraction, square root of 6 minus square root of 2 over 4, and that is the correct answer. All right, let me stop now, and maybe one more video to finish out this review.